Okay, so this is part 2 of 6.3. So we have already done 1 and 2. And now we're on to C. So first we want to deal with the A term. And since we are not trying to find the factored form of the equation, we're just looking for the x-intercept. So find the x-intercept in the coordinate of the vertex. We know that we want our y to equal 0. So we can actually just put that out there right away. If we're looking for the equation in factored form, then we don't need to do that. If we're just looking for the x-intercepts, we know we're going to get y equaling 0. Then we can factor out this negative in front of there. So remembering we need to factor it out of every term, so changing all of the signs. The other way to think about that, and now we can divide it out of both sides and really just get rid of it. The textbook doesn't get rid of it in the example, but we can really just get rid of it. We're not going to use that again. The other way to think of it is how I did it on Zoom this morning, is to think of it as dividing every term by -1 on both sides. And that gives us our flipped. Excuse me. All right, let's erase that one so we can have more room, but that's getting us to that step. Now if we look, remember our rules. So those rules on page 263, again, write them down, copy them out. The 4 or 5 different ways to factor a trinomial, factor a quadratic equation, use them. Because we could figure out 2 terms that multiply to C and add to B, but we have a rule that says a squared, in this case minus, a squared minus 2ab plus b squared equals a minus b all squared. So we already have a rule there. So we know that we can find the square root of x squared is x. The square root of 9 is 3. If we take 3 times it by 2, that's going to be 6. And add the x. So we've got 6x there. So this is a perfect trinomial square already. So we can just say 0 equals x minus 3 all squared. We don't have to put any extra work. We just have to remember that rule. That one's not as big to remember as the one we were talking about today, because you could factor this out by going, all right, 3 times 3, or -3 times -3 is +9. -3 plus -3 is -6. Therefore, I know I've got x minus 3, x minus 3. It could do it that way. The rule you really need to remember that you can't really do any other way is the x squared minus the difference of squares. That one you do need to recognize because there is no other way to really figure it out in most cases. All right, so we've got our x's, but they're both the same. So it's the same as saying x minus 3, x minus 3. So rather than have an a times a b, we've got 2 a's. So we know there's only going to be one answer for x. X is going to equal 3. So what does that mean? So there are multiple types of parabolas. We pretty much have 3 different types. Both opening up and opening down. We've got ones that look like this or like this that cross the x-axis twice. Those are what we've been working with so far. But now we also have ones that look like this or like this that never cross the x-axis. So they have no real roots. And we're going to talk about this in another lesson. Those ones have no real roots. They do not cross the x-axis. They have no x-intercept. The one we're looking at right now, and let's fill in our numbers first. Let's spread it out a little bit here. 1, 2, 3, 4. Again, doing our numbers in right on the line so we know which line which is which. And having at least 3 on either direction so that we know what our scale is. So now we've got one x-intercept. We've got one x-intercept, and because going back to our original equation, it is negative, we know that's going to be opening down. So we've got a negative a, so we know we are opening down. That might be the reason that they want us to keep this -1 in front of here, so that we remember that. But it doesn't come into play in finding that 3. But we do have to remember that it's negative in the original equation. So we are going to be facing down. So because it is negative x, we already know our pattern is going to be over 1, down 1, over 1, down 3. So we can just draw that in. And there's our parabola. So coordinate of the vertex. So because we know that the vertex is on the x-axis, we already know that it's going to be 3 and 0. We don't need to do anything else to figure that out because it only hits once. There's 2 options when we have 1. It's either a positive vertex or a positive parabola because A is positive. A is positive. Or A is negative and it's facing down. So if we only have 1 because we've got a square like this, then we only have 1 real root. Or 1, 0, or 1 x-intercept. So we know that point is either the minimum or maximum. I always want to put maximum point. And so that's the vertex, regardless of where it is. So the other one is just an example if it was positive, but ours is negative. So I'll erase that one so it doesn't get confusing if you're looking at that after. But our vertex is our x-intercept because we only have 1 real root in this example. All right, what does the book say about this? So if you want to pause and look at this, or look at what it's telling you on pages 284 to 286. These are the answers out of the textbook for this example. Come on. So example 2, find an equation from the graph. So this is kind of backwards. Now they're giving us a graph, they're giving us certain points, and we need to figure it out from there. So we got to look at what information we have. So we have a random point up here, just a point. We have an x-intercept down here. We have an x-intercept over here. So we've got our two roots, or our two zeros. So these are called roots or zeros or x-intercepts. I don't know if there's any other words for them, but definitely those are all what they're called. We don't exactly know the vertex yet, though I bet you could guess pretty accurately by looking at this graph. And we kind of, though it's not stated, we kind of also have the y-intercept. Again, we could guess and be pretty accurate to figure that out as well. But let's just stick with the actual information that we have, because this could be a 1.002 sort of vertex. We don't want to jump to conclusions. So what we do know, we want it to eventually be in the form y equals ax squared plus bx plus c. But what we can do is start off in the form like this, because we do know our x-intercept, so we do have the factored form. What we don't have is a. So we know one of our x's intercepts is -2, one of them is 4. So x minus minus 2 x minus 4. Put them in the brackets at first just to make sure that you're understanding how to change the signs here. So now we've got almost all the information we need. We're just missing our a. So that is where our random point comes in. We've got an x and we've got a y of a random point. So if we substitute those into the equation, then we are going to have enough information to find our a. Because a is going to be the same on any point of the graph, but we can solve it by using one specific point of the graph. So we've got 16 as our y. Again, put them in brackets just to make it in case there's any negatives that you need to deal with. So 16 equals a. Remember, we're adding. Just because there's brackets doesn't mean that we are multiplying. We are adding that. So 2 plus 2 is 4. 2 minus 4 is minus 2. A times -8. And now we want to remember that now we're multiplying, because now we've got that -8 is inside the brackets. Those brackets mean multiplication. There's nothing in between. Let's use a different color. So if that confuses you, know that the plus sign is in between the bracket and the number. There is nothing in between the a and the number, so that's multiplication. So understanding the language of math is important. It's like commas and periods and exclamation marks in language. They all have meaning even though you don't say things. So when there's a plus between the number and the bracket, you're adding. If there's nothing there, then you're multiplying. So in order to get rid of that, we divide that -8 on both sides. And we end up with -16 over 8, which ends up being -2 equals a. So now we've got our a, and we can put that back into our formula, or a expression, our equation at the top. So I'm going to put the y's back in, the y and the x back in, but now I've got -2, and we know that's probably correct because if we look at it, we know it's going to be negative because it's pointing down. So having a -2 sounds correct. x plus 2, x minus 4. Now I want it to be in standard form, and this is factored form, so I want to expand. So we're going to go back to our FOIL. We're going to do first, outer, inner, last. We're going to do 4 multiplications there. We're going to keep that -2 on the outside of the bracket first, so we can finish everything that's inside. We end up with x squared minus 4x plus 2x minus 8, all inside the brackets. First, I want to simplify what's inside the brackets by putting that -4 and the plus 2 together, since they both have an x term. So I end up with minus 2x, minus 8. Now I'm going to bring in my 2x, my -2, and I'm going to expand it, bringing it into every term. So -2 times x squared, -2x squared. -2 times -2x, positive 4x. Multiplication, negative times a negative is a positive. -2 times -8, positive 16. So now I have, write an equation in the form y equals ax squared plus bx plus c for the parabola shown. This is my final equation. Put a box around that to show you that that is complete. And there's your solution, textbook style. All right, last example and we're done. To commemorate the 100th anniversary of Newtonville Fair, an entrance arch will be built. The design engineer uses the equation h equals -d squared plus 16. So look at this one again. What's special about that? We've got 2 squares. We've got a d squared, which can easily be there, and we've got a 16 squared that can easily be square rooted. So we just need to worry about that negative. Let's finish reading it first. The design engineer uses the equation h equals -d squared plus 16 to model the arch, where h is height in meters. So we always want to underline our important information. Above the ground, and d is the distance horizontally in meters from the center of the arch. How wide and how tall is the arch? For what value of d is the relation valid? Explain. If a width of 2.5 meters is needed per lineup at the entrance, how many lineups can there be? All right, a few different pieces of information there. How wide and how tall is the arch? So we want to know, we've got an arch. We know that h is height, so h is always going to be there. D is distance. So what we're really looking for as far as how wide, we're looking for the 2 x-intercepts. How high? We're looking for that vertex. So we always need to know what is it that we are looking for. So actually we're going to put the h right in the middle there. We're going to figure that out. So it will be our vertex. It will also, in this case, be our y-intercept. Did I leave myself room to work on this? Yes, I did. Okay, so how wide and how tall is the arch? So let's work on wide first. Let's figure out what these x-intercepts are going to be. So I need to know what it is in factored form to know what the x-intercepts. So how wide? I want to know the x-intercepts. That's going to be able to help me figure out that information. No, I didn't leave myself any more room. Okay, so I want to be able to draw it too. So how wide is it? We're looking for x-intercepts. So we're starting off with h equals negative d squared plus 16. So when we don't have a d term, look for a difference of squares. If I factor out that first negative, I then have d squared minus 16. And now I've got this rule again inside my bracket. So where I've got an a squared minus a b squared equals a minus b, a plus b inside that brackets. So I know that the square root of d squared equals d, and the square root of 16 equals 4. So I can just jump that into two brackets. And I'm going to keep that external negative hanging around so that we remember that we've got an arch that opens down. So now I can break it up if we want a height of 0, because we were trying to find our x-intercepts. Our height is going to be 0 because we're touching the ground. Then we can say d minus 4 equals 0 or d equals 4. And d plus 4 equals 0 or d equals negative 4. So we've got two options to figure it out. So if we graph that, 4, 1, 2, 3, 4, 4, 3, 2, 1, 1, 2, 3, 4, minus, 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 minus. We know our x-intercepts are going to be negative 4, 0, and 4, 0. But this isn't what the question's actually asking. What the question's actually asking is what is, or how wide it is. So we can see that we're going negative 4 meters and we're going positive 4 meters. So we know the arch is 8 meters wide. We're making an arch that's going 8 meters wide. So now we need to figure out how tall it is. And the question already gives us to us. So how tall, which means right now we know we're centered on the y-axis because we are equal distances backwards and forwards. So we know our axis of symmetry is going to be x equals 0. So our axis of symmetry, x equals 0. We know that's our center line. So we know that x equals 0, our d equals 0, sorry, in this case, because d is our x. So if we took the equation and substituted in a 0 for our d, we've just got h equals 16, which again, if this is standard form over here, our c value, since we don't have a b value in this one, our c value is our x-intercept. Something we already knew. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Not very good graph making, but you get the point. We've got 0, 16 as our vertex. So we can draw in our arch as best we can. And it doesn't go below the ground, but just to continue our parabola. Oops, too far. So that is our arch. So we know the arch is 16 meters high. For what value of D is the relation valued? So this is our domain and our range that we talked about in chapter 4. So the values of D. D is only valid between -4 and 4. So there is no value below that. If we were at -5 or +5 or anything bigger than that, there is no arch. The arch doesn't exist past those lines. So our arch only exists between -4 and 4. And the way we write that is -4 is less than or equal to D that is less than or equal to 4. And we could even write in when 4 belongs to the set of real numbers, but we don't need to do that. But this is how we write domain. So -4 is less than or equal to D, which is less than or equal to 4. That's the only time where we have an X value on this arch. Anything bigger or lower than that is not working. So C, well, that's B. C, if a width of 2.5 meters is needed per lineup at the entrance, how many lineups can there be? So we have 8. We have 8 meters. We want to divide them by 2.5. How many 2.5s can we have in there? So if we did 8 divided by 2.5, we end up with 3.2, which we can't have 0.2 of a lineup. So can have 3 lineups. So basically they're saying we need this much space for this lineup, we need this much space for this lineup, we need this much space for that lineup. We've got a little bit of room in between. So we've got a line up here, we got a line up here, we got a line up here. So it's just, C is just making sure that you understand what your information is asking you. So the bottom of the arch is 8 meters wide. We want lineups of 2.5 meters wide. How many can we fit? That's all it's asking you. So really need to understand what the information you have in front of you in order to get that. Here is our solution textbook style. Pause, read it over, see if that matches what I told you. Key concepts of this day. The x-intercept of some quadratic relations in the form y equals ax squared plus bx plus c can be found by factoring. So when we have the factored form, we can write it, sometimes it turns out looking like this. Or sometimes when we have, it gets more complicated and we've got coefficients involved inside. So either way we can find, no matter how complicated it looks, we can solve by using the factored form. A quadratic relation can be graphed by using its x-intercepts. For example, to find the x-intercept of the quadratic relation y equals x squared minus 2x minus 3. Factor and solve the corresponding quadratic equation by letting y equals 0. So when y equals 0, we are looking at y being 0. We know we're on the x-intercept, so we're finding the x-intercepts. So we can factor it by doing this. Then we make each one of the things in the bracket equal to 0 to solve for our two possible x's. Since the roots of x squared minus 2x minus 3 equals 0 are 3 and negative 1, the x-intercepts are 3 and negative 1. The x-intercepts are zeros, so understand that we can call them zeros, we can call them x-intercepts, or we can call them roots of a quadratic relation of y equals ax squared plus bx plus c are the solution to ax squared plus bx plus c equals 0. So when we find the x-intercepts, y equals 0. The x-coordinates of the vertex is on the axis of symmetry, which passes through the midpoint of the line segment connecting the x-intercept. Substitute the value into the quadratic relations to find the y-coordinate of the vertex. So if we've got an x here and an x here, we know the axis of symmetry is directly in the middle, the midpoint of the two x's. Doesn't matter where the y vertex, where the y is, it could be over here, but the midpoint between the two x-intercepts is our axis of symmetry, which is also the vertex, the x of the vertex. Then we just substitute that x in to find the y. When the x-intercept and the one other points are known, the information can be substituted into y equals a, x minus r, x minus s to find an equation representing the relations. So when we have x-intercepts, we can put them in here, and then we can solve, as long as we have one other point to put in our x's and y's, we can then solve for a. So that is example 3. All right, so find your homework attached to your Google Classroom, and look at the practice questions for today and the overall homework, and we are done.